line segment joins the midpoint, so I see the word midpoint of two sides of a triangle, then its length is equal to half the length of the third side. So I think the biggest challenge for many is drawing the picture. So I'll alleviate your worries on your test. The picture is given to you guys. You will have some points, just like some of the problems above that were guided, and you guys just have to provide the coordinate points for the other parts. Okay, so let's go ahead and sketch the picture. So we have a triangle. They notice that in that description, they didn't mention anything about the triangle having to be a right triangle or having to be an isosceles triangle. So I'm going to purposefully draw it so that it's scaling, that all the sides are not congruent to each other, just so I know in my mind I can't make certain assumptions. Okay, so also the guidance was that when we're doing these coordinate proofs, we put one of the sides on either the x-axis or the y-axis or both, and one of the vertex on the origin. So let's go ahead and do that. Let's put one of the sides on the third side on the x-axis, and then the two other sides I'm going to draw so that they're not congruent to each other, because it did not mention that they were a that this was an isosceles triangle. Also, I know I kind of drew that, so it looked like every time I try not to draw a right triangle, it comes out as a right triangle, but we don't know that that's a right triangle. That's not in the description at all. And then lastly, we'll label like coordinate points. Okay, so this is A, B, and C. And then they also describe, for a portion of it, they described if a line segment, which I'm going to draw in yellow. So this is the part that is, so it says, if the line segments joining the midpoints of the two sides. So what they're describing is what I just underlined in yellow is if I were to find the midpoints of these two sides of the triangle and connect those two, they're saying, can you show that that yellow segment is half of the third side? And by third side, they're referring to AC. So now this is from your Monday night's homework from the textbook. So you guys should have it either completed already. A lot of you guys already did it. Or if you completed it and it wasn't correct, just do it along with me on that homework assignment or just in your notebook somewhere if you haven't started the homework. This is page 307 in your textbook. Okay, so now going back to that yellow segment, I don't have coordinate points for those either. So I'm going to call it M and N. Okay, and now we have to basically assign variables to it. So what I'm going to do is focus on A, B, C first. And let's say A, super easy. That's the origin, so 0, 0. Okay, C is some unit, some X unit away from A. What I notice is that sometimes it's helpful for me if I know that there's going to be a reference to a midpoint at all, that I just use a variable that is 2 times or has a coefficient of 2 in it, just to make it a little bit easier for calculations. Now, it's not going to help with this problem, but sometimes it does, so I try to do that. If I was strategic about it and thinking way ahead, I could have made it 3A, but I didn't want to confuse you guys any further with that. So what I'm going to say for this one, though, is you guys can, let's say someone in 5th period said, I picked this to be just A. That would not be incorrect. That's fine. You guys can pick this to be whatever you want. Remember, if the picture is not given to you, you just have to get comfortable with the fact that there's more than one possible answer. But then what he did say was the rest of his work corresponded with mine, and we came to the same conclusion. And that's fine. That's okay to do with these proofs. Okay, so let's say we define this as 2A0. Normally, B in the problems that we've done, B was like the vertex of an isosceles triangle. So we could automatically assume it's going to be half of A. But right here, I drew it skewed because this is actually a scalene triangle. So we don't know what this distance is technically. So that means whenever we don't know, we have to assign a new variable. So since I'm going with A, let's go ahead and call the X value B. And Cody could have drawn the triangle so that it's flatter. And then Aman could have drawn the triangle so it's taller. So technically, we don't know what this Y value is of B either. So that means we've already used A, B. Let's assign a different variable to it. It's got to be different because there's no relationship to little b or little a. Okay, so then after that, we now go back and come up with our coordinate points for the yellow ones. And so the yellow ones are dependent on the other ones that you guys already defined. So I'm going to do this one with you guys because it's harder. But when you're looking at the midpoint, remember the midpoint formula is you average the x's and then you average the y's. So if I average the x, then I get 2a plus b divided by 2. Okay, so I simply took the x values, added it, and then divided by 2. Can you guys type into the chat, what do you think the y coordinate is for this point? What do you think the y coordinate is? Remember, you guys are finding the midpoint, so what is the y coordinate? Good. Perfect. Okay, so some of you guys put 0 plus c divided by 2. Some of you guys simplified that out and just put c over 2, and other people put half of c. Those are all correct, right? You just add c plus 0, divide by 2, we get c over 2. Now, on the other side, you guys have m. And m is the midpoint of AB. So can you guys tell me, what do you think the coordinate point is for m? What's the coordinate point for m if it's the midpoint of AB? Deplina? Okay, so if I'm trying to find the midpoint of point A and point B, I'm adding up my x values, so b plus 0 divided by 2, and then my y's, c plus 0 divided by 2. So if I simplify that, good for those of you guys typing it in, it's b over 2 and c over 2. Okay, that's, to me, that's like the hardest part, is trying to figure out, what does this picture look like? How do I assign these variables? Then the next part was, if we read the question again, it wants me to show that the line segment, so that yellow one is half the length of the third side, which is AC. So how do you guys, what do you guys think of when they says length? What formula do you guys think of if you're trying to show something about length? What formula do you guys have to use? Distance formula, yes. Okay, so we're gonna first find the length of, remember when we draw or write MN without the bar on top, that's saying that's the measurement or the length of segment MN. So we're gonna first start with the distance formula for that one. So for this one, we're gonna take the change in X. So that means I'm gonna circle the X's. We're gonna take 2A plus B over 2 and subtract out b over 2. I mean, it looks messy, but it's actually going to work out really nicely. And then we do the change in y, which I'm going to put a box around. Okay, the change in y is as expected. It's a flat line. So c over 2 minus c over 2, we would expect to be 0. And if we simplify this out, we end up with, look what happens here. You guys have a common denominator. So really you guys have 2a plus b minus b on top all over 2 squared. And then c over 2 minus c over 2 is 0, and 0 squared is just 0. Can I ask you guys, what happens to the b's in the change of x? What happens to b's? Yeah, they cancel out, right? B minus b is 0. What happens to the 2a over 2? What is 2a over 2 equal? Becomes just a, right? So all of that just becomes square root of a squared. And if we remember, the square root and squaring, they undo each other. So this just simplifies out nicely to just a. Okay, so then that's going to be the length of MN. Now I have to find the length of AC. So with AC, that one's going to be much easier to do. If I do the change in X, I'm going to circle the change in X. It's 2a minus 0 squared plus the change in Y, which I'm going to box. Change in Y is super easy. It's 0 minus 0 squared. And so I'm left with the square root of 2a squared. So if I take the square root of something that's being squared, then it will undo each other and I get just 2a. Did I show what I was supposed to show? That the yellow is half the length of AC. Is that true? Does that prove that what I wanted to show was accurate? Okay, yes. And then I would say with all coordinate geometries, you guys are going to get a fill in the blank statement. So it would say something to the effect for this proof. It would say that that mn is blank of AC, and you would have to say double. How did you get to a after the exponent? The square root, that's the operation square root of something squared is just what's inside. They undo each other because 2a times 2a is 4a squared. That's what a square root does, right? Okay, so your conclusion is going to be, so therefore, AC is twice the length of the segment connecting the midpoints of the two sides of the triangle.